Hi, my name is Jorge Guerra Pires. Here I'm talking on behalf of the other of the group, which is the PhD student called Ilaria Petrantoni, and the Professor Roberto Maggio, which is a kind of supervisor. He was the person that introduced myself to Ilaria, and we intend to have him as a kind of external eyes of the project. On this video, I'm going to explain you in short words what is the project, what is the main goal, and since initially we intend to make something very nice, of course you may try to find the definition of what is very nice, and you can say that the movie full of animation and the special effect is very nice, or something very scientifically plausible is very nice. So the definition of very nice can change a lot, but we are engaged to make something as nice as possible. So on this video, which is the first video of the project, we are trying to set the goals to explain the reason of the existence of the project. This project was born. I created the idea, came to me 2 months ago, and I have sent a proposal to Professor Maggio, and we discussed by mail, and finally after several problems to meet, we were able to meet, and we decided to go on with the project, and Hilaria got interested by the project, and we start to decide to make this project to exist. As we are going to see, on the slide, the main goal of the project is very simple. It's to create a course about biomathematics. So how far we are going to achieve, it's a good question that we don't know. So it's a project that we intend as well to learn all over the project. We intend as well to achieve new stuff that we could not calculate. So I think the minimum that the basic that we plan to achieve is a set of videos that will be available on YouTube, likely a set of posts and a set of ideas that is about biomathematics. We do not intend to propose anything new. We do not intend to propose a new era of knowledge. We do not intend to propose anything at all. We just our own goal here is to spread out information, to make our own interpretation of what exists. So it's not nothing about to propose what is biomathematics, nothing about propose a definition for biomathematics. It's not about anything like this. It's just about to take what exists in the literature and make it in such a way that the general public can learn, can see it, and as well in the end to propose. This is the point that in which we propose a course, a set of a prototype for a course in biomathematics. My background is engineering and mathematics and life science. I have statistical biology and so on. Ilaris has a background in biology, and now she's doing a PhD in medicine. Professor Marge is a doctor. He has a background in medicine, work with pharmacokinetics and thermodynamics. And we hope that as well in the partnership we are going to learn with each other and to enforce our let's say engagement, our work as a group. So nowadays it's getting easier and easier to spread out information. Let's say in the past the only way that you could make information go on was by journal, and they were even not digital as is today. Today the printed journal very each time more and more rare to find, useless somehow, because for example I have books that's from very nice journals and paper that I stay in my room but never use it. You always use the digital version. It's easy to can access it from wherever you are. You can just have it, just need access to internet. You need a digital version to access. And so since this is a new project, the advantage of the new project as a new idea that you can adapt to what's going on. And today you have a rain of YouTube videos, and you have famous universities as Harvard, MIT. They're very famous. They have YouTube channels in which they publish lessons and so on. And we plan as well to make use of that, because mainly because it's not available, and because it's a new project, so we have no other way to do it, because we cannot, for example, at the current moment, as we discussed during our last discussion, at the current moment you cannot make it otherwise, because YouTube is that cheap, you don't have to pay, there is no charge and so on. You cannot make it like as a conventional course right now. And maybe, at least I talk to myself, even if I could, I don't know if I would, because I mean, the conventional courses are full of rules, and by make this kind of course the way we are doing, we expect to have more flexibility that you would not have otherwise. YouTube it's very famous. You have from bad stuff, from good stuff. So it's not a very good place with your reputation. So you can ask me, why should I trust you? I mean, the group behind, I believe, is respectable. You are using a very easy way to publish, but you have a very good group. I believe it's not like very famous, but we have PhD students that we are working, we are scientists that we take serious what you do. So the videos, in order to make your life easier, the videos are going to be divided into three groups. The first one is the project itself, which is called the Crash Course in Biomathematics. So this is the project, this is the core, where this is the main, are going to be the main videos, and have some miscellaneous videos, which are videos that can be useful, such as I'm planning to post, for example, videos for my papers that there are ideas I have developed so far. I believe they could help to defend the channel and the project itself. And the others, well, for example, if someone follows the channel, it could happen that you don't know yet. You don't most of the things about this project, about the channel, about everything you have to define. So you don't know yet about what's going on. You don't know yet about how far we are going to arrive, and which kind of achievement we are going to achieve. So maybe we can be lucky enough that someone has very nice videos and would like as well to post alongside our video. So you just have to send us, and you will let us know somehow why you want to publish it alongside our videos. And the partnership is always welcome, especially when they bring to us new achievement, enforcement of what we are doing. And today, if for example, if you already have a YouTube channel, you already upload the video, do not have even to send the video, just have to send the link. So you can post the link in the playlist, and it appear in the YouTube channel as a conventional video. So it's not very easy to talk about this kind of question here, because the easiest one could be what is the crash course about biomathematics. So the crash course, the name crash comes, I'm not quite sure if you are familiar, but for the first time I heard crash course is a course that's very small. So but I have not some doubt about the term crash course. I decided to keep it because I believe from the point of view of grammar in English, it's not wrong. Maybe not everyone is familiar, but I have read this kind of crash course. So the crash course is a course that's very short, that's supposed to be very short. I'm in the YouTube, since you have a lot of space without any expense, and people can see whatever they want, they do not have to watch everything. You, I think, to post maybe a lot, but if you succeed to go to the end of the project, you succeed to have a course that is a classroom like course, a course that is taught in a classroom. So in this case, like 5 to 10 hours, that's the idea, to 5 to 10 hours, like 1 hour each module. So in doing this time of 10 hours or 5 hours, we discuss from theory to code and mathematics. So the second question, more important, what's biomathematics? So it seems to have no, at least I'm not aware of any serious attempt to say what's biomathematics, the origin of biomathematics. Likely, I think it's because biomathematics itself is very complex to define. In the beginning, as you already know from the Greek miracle, when in the age of reason and so on, we had all field of science as a unified investigation. They have no separation, they have no physics and mathematics we have today. The one of the biggest difference came from Newton. Newton, until his time, it was called natural science. So after him, we start to have most of the division, and all the other division was created after him, such as biology, one example, chemistry, another example. So they were created step by step. As we evolved, we saw the necessity to separate the area in order to study a specific idea or a specific set of experiment. So one can say that biomathematics came from the last century, mainly because the last century had such scientists such as Nicholas Niboskowski. I'm not quite sure about the pronunciation of his name, but he was very famous. There was as well, I don't remember quite well, but there's some scientists from quantum mechanics that had some contribution. Even Schrödinger, wrote a book, What is Life, and he proposed in his book some kind of challenge that the physics itself will be unable to tackle. And one of them was protein. The photon of protein was somehow implicitly predicted by Schrödinger, which was a physicist that worked with that extended somehow the work of Albert Einstein, and it was influenced somehow by Albert Einstein. There's a history say of physics. So a precise definition of what biomathematics is very complicated, but for example, you can say that biomathematics is an abstract name for any effort regarding making the life science more precise, with some attempt trying to create general principles and laws, such as we have in physics. So some might say that this definition here is biophysics. Anyway, for me, honestly, I think biophysics and biomathematics, they are the same. So they are just an attempt to make because today I believe each time more physics and mathematics are not so different more. So when you talk about physics, talk about mathematics, they are the same. If you want to make the separation, for me it's not a problem, I believe. But for now, we are assuming here that biophysics and biomathematics, they are the same. So it was developed, I mean, the way we see biomathematics today was developed mainly in the last century. I'm not talking about the origin, I'm talking about the core, the main ideas, the cornerstone was developed mainly in the last century. The name biomathematics was used mainly in the last century, I believe, especially because biology itself came from the 19th century. At that time, they wanted to study the origin of life, such as, you don't know too much, for example, in the case of Lavoisier. Antoine Lavoisier was famous for results of the oxygen. He discovered the oxygen, not discovered, he reinvented, as some say, the oxygen. He saw some research of Presley, and from that result he did a precise calculation, proved that something was there, and called that stuff oxygen, emits oxygen. So biologists arrived trying to explain stuff such as Lavoisier did the mistake saying that the carbon was just present in living systems. So this kind of idea that was wrong from the past was fixed by the new biologists that was mainly called biology in the 19th century. So biomathematics, which is a mathematics itself, I wrote in a paper recently, it was in 2013, 2 years ago, that this name biomathematics is going to disappear, mainly because nowadays the engagement, the overlapping of the areas of research is getting each time more and more common. So in a matter of time, it will be useless for us to talk about the biomathematics bioengineering. There will be just one and just the same. So biomathematics gives us several luxuries, several advantages, such as if you understand a system properly, you can automate such as maybe one example would be, let's say a practical example would be recently I was in a doctor recently as at the university asked every student, every professor, let's say everyone to go to the doctor to make a checkout. And I remember that in the beginning you had to fulfill a kind of form. So imagine if that form after fulfill could do it by internet, or even after fulfill it a computer will make the screen of the information. But that case a doctor needs to do that. So imagine that the time of a doctor is like he working if he forms. It's a waste of time. So nowadays with the internet, as I have explained in the beginning, we have the advantage and disadvantages. So we need to make a trade-off between that and see what the best way for a kind of situation. In our situation, I think we are going to adopt a middle way between email and Facebook. Because, email is very nice because you can exchange mail with your colleagues and so on and so on. Even Einstein, in the time of Einstein, he, as you see from the history, when he was not still famous, he was still publishing his paper. It was like more than 10 years without being recognized after publishing first paper on the special theory of relativity, and also his paper about Planck motion, and also kind of the paper that today is called the five miracles, the fabulous papers of Einstein. The other way, there's a Facebook that it's a very dangerous place. You can exchange ideas with your friend, you can divulgate your work, but as well you can be very informal. We are in the middle way. We have a page Facebook. You are welcome to visit. If you like it, we know that somebody is supporting our work. And we have as well a YouTube channel, as you saw in the beginning, blog, site. There is a page on my own website. I have created a page on my own website. The blog, you can see it or whatever you want. So the YouTube channel that I have explained before has have a set of videos as we saw here. This kind of video. Now we're going to check firstly what it is. So the crash course it's a list. It's a playlist that will be carefully monitored. We are going to try to do our best to ask people to give opinion, to give form, to send electronic form, and to see how people are reacting to the content of the course. So all the videos from the playlist will be submitted for a screen process. Screen process are going to be made by likely the response of the public. So the second one, it will be potential. It's a miscellaneous, which is supposed to be very, 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 very. Let's say examples. Let's say case study. Anything that we calculate that could be strong could be very important. The second one is supposed to be a, let's say, a more flexible type of vid. Maybe this group of vid are not going even to exist. But the one that is really important is this one. This is the list that are going to be really, really monitored. As opposed to this is the one that we are engaged to produce. So as I explained before, the problem of the copyright something very serious. So, but here we are going to make the license as flexible as possible. This is the most flexible license of the Creative Commons. And since this is a joint effort, we are not working alone. I'm talking here on the behalf of the other group. We after finish this project, this YouTube channel going to be kept for historical reasons as well, the blog and so on. Historical reason mean that we are not going to change it, so it will be out of date soon, depending on the content that you stay. For example, if you teach how to use biomathematics, it's not get to be outdated. The techniques stay forever if you teach how to use it. So we intend to follow a several step called brainstorm, screen, final version. At the moment you are in the brainstorm, the beginning. So brainstorm means that you produce as much as you can. And the screen means that you use a kind of criteria such as this kind of vid that it does not have direct contact with biomathematics was supposed to be removed. So screen means that you apply a kind of rule in order to remove a kind of stuff. Screen in general is used in development of new products in the industry in order to start from a set of ideas called brainstorm and to create a final version of the product to go to the market. So as the sense came to me, I idea that we could see this YouTube channel and the project as well as a product, which means a product. A product means that we need to you are going to try to apply some methodology for the development of new product. Such as when you buy a cell phone, when you buy your smartphone and so on, it is a product. Product means that it was designed for a public, that the public was somehow studied, the public was somehow heard, and then it was created that was designed for a client, for a customer. So the main output of the project is a prototype. The prototype for a short course in biomathematics, which will be specially designed for someone that does not have a background in biomathematics, such as a biologist, applied mathematician, someone that wants to study biomathematics. As well, we can say that we have extra achievements, such as if you treat all these projects as a product, you have a nice paper. Let's say if you treat that as a product and you succeed. So you have a very nice paper to write about the design development of a new product. And as well, if you succeed, you can create a tutorial that you just write down all the stuff here. You have tutorial, and as well, you can create some example, because the idea initially you should take a classical book of biomathematics and study them, and to take the example of this book and translate them into our own ways of thinking. But you can as well create our own example. Can as well, for them, take an example of paper. As well, I have several examples published, so I can use those examples. But the idea is that this course will be self-content. We are going to try to avoid to use material that has already been published, unless they are classical examples, because we would like to have the opportunity to create something new instead of repeating old wrong styles of thinking. As I explained before, it was created several social networks. So let's say people can start following, such as YouTube, you can subscribe, blog can follow, Google can follow, and so on. And I work with Java for a very long time, so as I go on, I can easily create code in Java, and if I succeed, I can make a software, and we work all together to make that free. MATLAB as well. But MATLAB is not free. If you have MATLAB, you can use the code for free, otherwise you cannot use it. Java is completely free. As long as you have the code, the virtual machine can run it. So what is the content of the course? It's not very easy. We still have a lot to define, but basically you can say that you have the technical details, which we need to produce. It's part of the course, otherwise there is no reason for this course to exist. And you also have some, let's say, planets, some topics that you can as well add to make the course more richer. Such as you can have materials for discussion, such as there's a paper you want to discuss, there's a model you want to discuss, which is not necessarily technical, which you cannot teach, but they are nice to discuss. You can include it in the YouTube, as well in the website, in the project as well. Let's say in the beginning, the step of brainstorm, you can do whatever you want. So philosophy shows that, for example, what's biomathematics, why that exists. Some big scientists in the past, such as Jacques, I forgot his name, Jacques Loeb, I think his name is Jacques Loeb. He was a very famous guy that he helped a lot in the development of engineering, biology, and so on. So it's kind of this kind of figure. They are very important in the development of biomathematics. Besides, most of it has not been recognized. So this could be interesting to add at least one video about this kind of of picture. Others could be more difficult to justify, such as Mendel, Gregor Mendel, that developed the Mendelian theory, the theory that they use in genetics. This is a kind of biomathematics, but it's not generally recognized. Historical issues such as the development of biomathematics in the last century, book comment and reviews such as have classical books that could be interesting to add some notes about them. It could be very important to have it. So biomathematics nowadays is suffering a very big problem that makes biomathematics very difficult to study. You have several branches. This one is not very common. It's called evolutionary computing. General people not say that it's biomathematics, but I think it's biomathematics. Evolutionary computing is a set of techniques used in computer science to solve problems. So they use inspiration from evolution. There is as well natural computing that uses inspiration from biology in general. So this technique they different from all of this technique here, if you accept of evolutionary computing, they are used to model. This one is used to solve the problem. So that's the difference. That's why people may say that's not biomathematics, because you can be able to model a problem but not be able to solve it. So everyone computer is a way to solve it. It's a technique to solve problems. So have several such as one of the biggest famous nowadays, system biology. If system biology have system biomedicine, system pharmacology, system physiology, and so on. There's a huge number of them. So we intend maybe to discuss which of them, some of them are system biology, almost surely what we're going to discuss. All those models said that even I don't know exactly what they do, I can maybe make a very short discussion. Mathematical biology is a very big name. You can say that mathematical biology studies mainly models that are mathematical, that such as when you study the population of cancer cells in the body. It's a kind of natural example of mathematical biology. The growth of a population based on a prey in the predator. So that's a very nice example. Mathematical physiology, bioengineering, biomedical engineering, biophysics, and synthetic biology. It's a nice thing to comment about the difference between synthetic biology and system biology. It's not very simple. Bioinformatics, theoretical biology, dry biology, someone like to call it, what you do in computer. Some people call it dry biology instead of wet biology. Wet biology is the classical biology. Dry biology is this new biology based on mathematical models. In silico, people make the difference in order to differentiate between in silico, in vitro, in vivo. In silico, computer, in vitro, laboratory experiment, in vivo, a human experiment. So basically, so can say that can just assume. I mean, for here, I'm going to assume that when you take mathematics and join with life science, you have biomathematics. So biomathematics here, we as well include physics. So physics for us is mathematics. So as any course, we need to be sure that we are sharpening the right skills. Here we are going to sharp, we are going to increase, to enhance, to improve the computer programming, mathematics, and life science. Of course, someone that comes to this course that is following the videos or even going to attend the classroom like course, if you arrive to this stage of the project, are going to have different level of expertise. Some of them might be very good in computer, others very good in mathematics, very good in life science. as every course you need to be sure that you have the right requirement, otherwise people do not understand what they're doing. So it's not very easy here to say the requirement, because that's one of the good point and bad point of biomathematics. We learn a lot about everything, so at the same time it's difficult to say what's going to be more important. Some situation you need to be very good in physiology, other situation have to be very good in mathematics, other situation have to be very good in computer science. So basically I would dare to say that if you have a familiarity with mathematics and the biometric science is more than enough. And as much as you can, you try to be self-content. What means self-content? Self-content means that all you need are going to be produced in the course. So in this project, we hope that we are going to keep the same, the same group, maybe to increase, not decrease. It's myself that I talk to you right now, Ilaria Pietrantoni, which is a PhD student of Professor Maggio, and she has a background in biology. Professor Maggio itself that he worked in pharmacokinetics, in thermodynamics, in the Professor of Medicine. So we welcome anyone that could be interested to collaborate. We don't know yet how long this project are going to last. Maybe even 1 year. I don't know. We don't know how long it is. I believe that the project production is nice. So the project, we say that as every project, you need to say that it's over, it ended. So for us, it ends when we deliver the prototype for a course in biomathematics. When hopefully we can implement ourselves, or maybe give the direction for somebody else to implement. Initially, that was something very interesting. That initially we just had a crash course in mathematics, but I have proposed, and I hope that we are going to do it very well, that you treat the course as a product. What the advantage means that you can apply methodology of design and development of new products, which I have used 5 years ago, not trying to make the best way, to deliver someone a product, and yes, you can get a very nice publication as well if you manage it very well. So I'll close here. That the video. That will be the first video that we are going to suppose to stay online until we were able to produce the video, the first video, which is the introduction of the course. So I'll close here. It's George happy to talk to you. And before this video go to publication, I'm waiting for the approval of Hilario Pietrotoni and as well in Professor Margin doesn't have to approve, but I hope he'll be following the video, and if you do let's say big mistakes, he are going to stop us.